Okay, welcome back. So for our prelim for week module number 2, so our topic is about equivalent circuit per phase of an alternator. So continuation ni siya sa atuang module 1. So we have here a diagram for Y connected alternator. Since Y, so kabalo na ta, if Y connected, so ana ang iyahang diagram. So natay EP and ay gadagan nga phase current. We have our voltage, line voltage. So naka 3 phase balance load na siya ha. So mao ni ato ang equivalent circuit per phase aning Y connected alternator nga diagram sa taas. So example, if we have DC source, so natay field windings sa ato ang alternator. So we have our phase current RP, JXP, and the phase current ug ato ang phase voltage sa tuang load. So let's have our formula for equivalent circuit sa atong alternator. So we have EP with an angle, power angle is equal to VP, the terminal voltage with an angle of 0 degrees, plus IP with an angle of positive or negative angle theta, multiply sa atong RP plus JXP. So take note that EP is induced EMF per phase. So kabalo na mo ani sa inyuhang electrical machine 1. So natagpuan ra siguro nato nino. And our terminal voltage per phase VP. IP is the current per phase. So atong current sa tuang windings. And our angle theta, positive if our power factor is leading. So negative ang atong angle theta if the power factor is lagging. And we have here our power angle. So angle between EP and BP. So na siya angle between ilang duha. And RP is the resistance of the winding per phase. And XP is the inductive reactance of the winding per phase. So basa na ay P per phase na siya ha. So let's have an example for this topic. So we have here a 100 kilovolt ampere, 4600 volt, 3-phase Y connected alternator has an armature resistance of 2 ohms per phase and asynchronous armature reactance of 20 ohms per phase. Find the full load generated voltage per phase at a power factor of 0.75 lagging. So first we need to write our given sa atuang problem para mas masabtan nato. So naghatag siya og S atuang apparent nga 100 kVA ni siya guys, 1000 kVA. So divided by S na to ha. So kVA man na siya, so pwede pod sa atong 1000 volt ampere. So pwede pod ana. And our line voltage, natag siya sa tuang line voltage ining 4600 volts and sa atuang power naghatag pud siya og R na to, RP nga 2 ohms per phase and XP nga 20 ohms per phase and our power factor nga 0.75 lagging. And our unknown is the EP, the full load generated voltage per phase. So first, since giingon sa problem nga Y connected alternator, so therefore our phase current is equal to line current. So nganong equal man ma'am? Since naka Y connected ang tuang alternator. So to solve for our phase current, IP is equal to, so formula S divided by square root of 3 line voltage. So we have 1,000, or mas gamiton nato ning isa para mas madali. 1 times 10 raised to the power of 6 divided by square root of 3, 4,600. So our phase current will be 125.51 amperes. So nanatay phase current. So our phase voltage, since ang gihatag is line voltage but per phase man, so we need to convert. So 4,600 divided by square root of 3. So our phase voltage will be 2,655.81 volts. And our angle theta, since naghatag og power factor nga 0.75 lagging, so our angle theta will be 41.41 degrees. So nakuha na nato ang atuang mga data. So pwede na ta makasolve sa atuang generated voltage per phase. So EP. So formula, diba, sa taas VP plus IP multiply sa atuang impedance per phase. So VP 2,655.81 with an angle of 0 degrees plus ang atong IP na 125.51 with ang angle of, since lagging, negative 41.41 degrees. And our ZP, we have 2 plus J20. So solving for EP, so calcu, our answer will be 4,820.43 with an angle of 20.86 degrees. But ang gipangayo is full load generated, so therefore ang real generated voltage is 4,820 per phase. So therefore this is our final answer for our example number 1. So sayon ra kaayo, no, since formula based ratanan and need lang nato i-analyze ang atuang given. So let's proceed for another example para mas masabtan pa. A three-phase synchronous generator has a negligible resistance and synchronous reactance of 2 ohms per phase. It is operated on an infinite bus having a voltage of 15 kilovolts. The internal EMF and the power angle of the machine are found to be 24 kilovolt line to line and 20 degrees respectively. So determine the total megawatts delivered to the system. So first, let's have our given sa atong problem. So naghatag siya og VL nga pila 15,000 kilovolts 15 kilovolts rather, and we have also for our EL line voltage na 24 kilovolts, and now I power angle. Gatag ba siya power angle? Wala, no? Na siya angle sa atuang 24. So na siya angle nga 25 degrees. Sa 24 kilovolts ni siya 25 degrees. And first, we need to solve for our phase voltage. So, since naka-line man ta, so we need to convert in phase voltage. So our 15 kilovolts, so 15,000 volts, sa 15 volts divided by square root of 3. So money formula if mag-convert tag line voltage to phase voltage. So 8,660.25 volts. So next that we need to EP. So itong generated phase voltage, we have 24,000 volts divided by square root of 3. So phase 13,856.4 volts. So to solve for our, ang unknown na to is the total megawatts. So syempre we need to solve for our phase current. So formula EP is equal to VP plus IP ZP. So we need to derive ani nga formula para makuha nato ang kaning phase current. So IP, so derive the IP is equal to EP minus VP divided by ZP. Sakto ba ito na derive? So substitute since given tanan. So we have 13,856.4 na siya angle nga 25 degrees minus 8,660.25 yung angle of 0 divided by ZP nga to na. So giingon sa problem na negligible ang resistance. So therefore ang given ra is reactance of 2 ohms per phase. So we have J2 ohms. So our phase current will be IP is 3,517.3 with an angle of negative 33.64 degrees ohm. So, na tayo phase current. So, to solve for the total megawatts, so for 3 phase, so you have power total is equal to 3 VP IP cosine theta. So, muna to ang formula for power in 3 phase. So, you have 3. Solve na nato ang VP nga 8,660.25. Ang ato ang IP na 3,517.3 with an angle of cosine theta of 33. So, kanina solve na to. 33.64 degrees. So, our total megawatts will be 76 megawatts. So, this is our final answer. That will be our total megawatts delivered to the system. So, proceed for another topic. For module 2, we have resistance test on alternators. So, the test is used to determine the resistance of the alternator windings per phase. With the direct current field winding open, measure the DC resistance between each pair of terminals. The average of the 3 sets of resistance values is called RT. So, summoning RT. So, RT is the resistance reading of the DC ohmmeter. And our RP is the resistance of the armature windings per phase. So, we have here for Y-connected windings, RP. So, muna siya ang resistance reading sa DC ohmmeter. For the formula for DC resistance for armature windings, sa Y na to, kani, Y connected windings, we have RP is equal to 1/2 multiply sa to ang resistance reading sa DC ohmmeter. So, for delta connected, we have here our diagram. So, our formula is RP is equal to 3/2 multiply sa tuang RT. So, formula lang. So, take note ha. So, take note, in practice, it is customary to multiply the DC resistance RP by a factor of 1.25 to 1.75 to obtain a value more nearly equal to the armature resistance when it carries alternating current. And next, we have open circuit tests on alternators. So, with the armature winding circuit open, the alternator is operated at synchronous speed. The field is adjusted so that an AC voltage between any pair of terminal is a little above rated line voltage of the alternator. So, we have here our diagram for open circuit tests in Y connected. So, we have EOC, open circuit ng OC ha. So, EOC is the open circuit voltage per phase. And V is the AC voltmeter reading during the test. So, kana mo na ito ang reading during the test. So, formula for open circuit voltage per phase, we have EOC is equal to V divided by square root of 3. For Y connected na siya. And for delta connected, so open circuit voltage is equal ra sa tuang voltmeter sa open circuit. So for short circuit, napunta short circuit test on alternators. So short circuit the 3 terminals of the alternator and connect 3 ammeters in each line to monitor the short circuit current. Run the alternator at rated synchronous speed starting with 0 excitation. Then gradually increase the excitation until the ammeters will read rated line current. So short circuit na to. So naatay Y connected o delta connected windings. So A mo ni ang easy ammeter reading during the test sa atuang short circuit current per phase. So formula for Y connected equal ra sila, and for the delta connected is ISC is equal to A over square root of 3. So delta ni siya. So take note for the formula. So for our last topic, for our module number 2, we have voltage regulation. So unsa man ning voltage regulation? So percentage voltage regulation is the percentage rise in voltage in the terminals of the alternator after the load is switched off. So natay percentage di ay sa tuang voltage. When an alternator is subjected to varying load, the voltage at the armature terminals varies to a certain extent. The amount of this variation determines the regulation of the machine. The numerical value of regulation is defined as the percentage rise in voltage when full load at the specified power factor is switched off. So the excitation being adjusted initially to give normal voltage. So we have here our equivalent circuit for our voltage regulation. So we have EP or the induced voltage per phase, and our RP, we all know that resistance and reactance JXP, and we have our phase current sa atong circuit, and we have the terminal voltage sa atuang load. So we have our formula for percentage voltage regulation. We have E for no load minus the full load divided by E in full load, or EP minus VP divided by VP. So we have also an alternate formula using per unit data. So naputay laing formula. So duha atong formula sa atuang voltage regulation. So we have here percentage is equal to square root of cosine theta plus percent regulation of I multiply sa atong resistance squared plus sine theta positive negative for a lagging PF o leading PF. So take note diri sa atong voltage regulation, positive sign siya if lagging. So take note siya, baliktad siya. And for negative sign if leading ang power factor. So plus minus percentage multiply sa tong I and X raised to the power of 2 minus 1. So sa gawas ang 1 ha, wala siya nasulod sa square root nato. So for formula ni siya if naghatag ang problem of per unit data or PU. Per unit data or PU. So napuntay laing formula for ZP. So wala na appeal dira. Hatag ni ma'am, ZP is equal to EOC divided by ISC. So combination nisa sa atuang open circuit o short circuit test. And our XP reactance per phase, we have square root of Zp squared minus Rp squared, where ang atong Xp is the inductive reactance kani of the winding per phase, and Zp is the synchronous impedance of the winding. So take note, if the PF o power factor is lagging, the voltage regulation is a positive value. While if the power factor is leading the voltage, the regulation is negative. So sa voltage regulation na baliktad siya. So if lagging di ay positive, if leading, negative sign. So let's have an example for voltage regulation. A 3-phase 50 Hz star connected 2000 kilovolt ampere 2300 volts alternators gives a short circuit current of 600 ampere for certain excitation. With the same excitation, the open circuit voltage is 900 volts. So the resistance between a pair of terminals is 0.12 ohms. Find the full load voltage regulation at 0.8 power factor lagging. So first, we need to write our given sa atuang problem. So naghatag siya og open circuit voltage na 900 volts, and we have we have also the RT from our resistance atong terminal. So RT is 0.12 ohms, and we have our S, the apparent power na 2000 kVA. And our line voltage mga 2300 volts. So maura ba ni? So nanataan ni volts. And naa siya ay na-solve na nato sa nana. Wala na tayo na power factor. Power factor nga 0.8 lagging. So atong i-solve is the voltage regulation. So first, we need to solve for our Zp. So itong Zp, ang atong synchronous impedance. So formula EOC divided by ISC. So sa atong problem giingon nga alternator. So take note, the alternator is Y connected. So naka-Y connected ang atoang alternator. So EOC, since naka open circuit voltage, so we need to convert that in phase. So square root of 3 divided by current nga 600 ampere. So our phase synchronous phase impedance is 0.866 ohms. And pwede po mo solve sa tong RP. So unsa gali ng RP? So ato ang RP is the DC resistance of the armature windings per phase. Since giingon Y connected, so we will use the 1/2 RT. So makita na asa man na formula ma'am. So makita na sa resistance test on alternator diri sa taas. So connected ra gyapon ni siya, no. So there are 1/2 RT. Substitute 1/2 na 0.12 ohms. So our RP will be 0.06 ohms. So pwede na to makasolve sa XP, the inductive reactance of the windings per phase. Formula XP is equal to square root of ZP squared minus RP squared. So na-solve na nato, square root of 0.866 squared minus 0.06 squared. So our XP will be 0.864 ohms. So nanatay XP. So to solve for phase current, since Y connected equal ra sa line current. So to solve, we have S, naman tayo given na S, divided by square root of 3 multiply sa tong line voltage. So ang S na to is 2000 kilovolt ampere. So volt ampere na to na, therefore 2 million volt ampere divided by square root of 3 multiply sa volt, line voltage 2300 given sa problem. So our phase current will be 502 amperes. So nanatay phase current. So kaon po na to ang phase voltage. So 2000, since naka-line, so convert square root of 3 gapon. Phase voltage will be 1328 volts. So nakuha na nato ang atuang mga data. So sa to'y formula to solve for the induced voltage per phase, we have EP is equal to VP plus IP ZP. So nakuha naman nato ng tulo. So substitute, we have 1328 atong phase voltage, una ng angle of 0 degrees, plus the I phase current 502, an angle of power factor na to nga 0.8 lagging, so negative 36.87 degrees, multiply sa toong ZP na to. So we have RP 0.06 plus J 0.864. So to solve for our phase voltage, our answer will be 1645.447 with an angle of 11.53 degrees. So take note kani volts per phase ni ang atoang answer. So to solve for our voltage regulation, percentage formula, EP minus VP over VP. Our EP is 1,645.447 minus atong VP 1328 divided by 1328. So our percentage voltage regulation will be 23.904%. So this is our final answer for our problem sa voltage regulation. So I hope nasabtan, no? And if you have any question, so this is our last example. So you have any question for our module number 2, you can comment sa ato ang Google Classroom and PM ni ma'am. So please study in advance para sa ato ang quiz. So study smart, and God bless.